In this video, we'll see how to find out the moment of a force. So the arrangement of the beam is shown in the figure. So you can see that there are three forces F1, F2 and F3, 200 Newton, 300 Newton and 400 Newton, making an angle of 60 degree with the horizontal as shown in the figure. The corresponding distances are also shown. Now we have to resolve the forces into its two rectangular component. Adjacent to the angle, the component is cos component. So force multiplied by cos 60. Vertical component is sine component. That is force, that is 200 multiplied by sine 60. 60 is the angle that it is making with the horizontal. Similarly, for this force of 300 Newton also, the horizontal component is 300 cos 60, vertical component is 300 sin 60. Then for this 400 Newton force also, the horizontal component is 400 cos 60 and vertical component is 400 sin 60. Now we have to find out the moment of each of these forces about point C. Now as you can see, we'll consider first this a resolved component of force F1. So 200 cos 60, its arrow will go in clockwise direction about point C. Then this 200 sin 60, its moment, its arrow will go in anti-clockwise direction. And we can say that suppose we assume the clockwise moment as positive and anti-clockwise moment as negative, then we can easily find out the moment of the force. So moment is nothing but force multiplied by perpendicular distance. Now this force is horizontal and the perpendicular distance about point C is 4. So it is 200 cos 60 into 4 and it is considered as positive because it is clockwise. Similarly, this 200 sin 60 is anti-clockwise. So it is negative. So that negative we have taken. And as this force is vertical force, we have to take into consideration the horizontal distance about point C, that is 3. So by making calculation, we'll get moment about point C as anti-clockwise moment because it is negative of minus 119.615 Newton meter. The force is in Newton and distance is in meter. So this force is in Newton and the distance is in meter. So unit of moment is Newton meter. Similarly, we'll consider the force F2. Now here the line of action of this 300 sin 60, it already passes through point C and therefore it will not have any moment about point C. So this 300 cos 60, which is horizontal, the perpendicular distance is, vertical distance is 4 meter and it will produce anti-clockwise moment about point C. So it is minus 300 cos 60 multiplied by 4. So it is minus 600 Newton meter. Now the force F3 will not have any moment. So its resolved component also passes through point C, correct? That is 400 cos 60 and 400 sin 60. The line of action passes through point C, so it will not have any moment about point C. So in this way, we can find out moment of the forces about the given point. Thank you very much for watching.